Hello everyone, and thank you very much for joining me again. Today we continue the discussion on Spring Start here, one of the most appreciated books in spring and probably the best appreciated of my books up to now. We continue with chapter 4 and I will share my screen immediately, but I wanted to remind you first that you have a live chat there, so if you join me live, remember you can ask the questions in the live chat. And of course, if you are not here with me live now, it's not a problem. You will probably watch this video recorded afterwards, so you still have the comments section where you can put your questions or topics or discussions or whatever you want. And remember that you can also and I do recommend you follow me on Twitter and LinkedIn or X or whatever the name of Twitter is now. With that being said, I don't want to spend too much of your time on commercials. I would like to simply step into the subject and discuss straight about our topic today, which is chapter 4. I invite you to look here on the left in the table of contents, where you can see that we went already through chapters 1, 2 and 3. If you are here with me for the first time, remember this is a playlist, so we already had like about 4 or 5 episodes before and we discussed the first 3 chapters. It's very important you take them in order because well, they build one upon the other, so if you miss and you don't understand some of the things we have discussed in the past, then you might not understand that, or we might find difficult the topics that we discuss now. So we have already discussed about spring, what it is, and we have discussed about beans, the context, and how you put the beans in the context, all the essentials way to do that. And then we discussed about wiring and auto wiring and dependency injection, and we continue today with dependency injection using abstractions. So this chapter is composed of 3 sections, as you can see here. So we start with what contracts are. I will go quickly through what interfaces are and how they define contracts and why do we do that. Normally I would prefer the minimally qualified reader of this book already know what an interface is and what a contract is, but I preferred to add this section also just to make sure. Why? Because it's very important, and I really didn't want to simply put the technicalities of using interfaces with Spring and not making sure upfront that the reader really knows this, and maybe someone really skipped over this part, or maybe they didn't have the chance to correctly put it in practice, and maybe they lack the knowledge. And to be honest with you, in my experience as a Java instructor and as a teacher, I've seen that this topic seems to be a difficult one to digest by the students. So first time the majority find interfaces difficult to understand, the interfaces versus abstract classes, why the two of them exist. Interface looks like something like a minimality of the abstract class, and they look like the same, almost the same, and they're actually very different. And the contracts and the interfaces that define contracts, they are essential to understand. So to me, it's one of the most important things Java developer needs to understand. So that's why even if normally here we discuss about Spring and how interfaces are used with Spring, I have started with this section discussing vanilla, the contracts and interfaces, just to make sure that everyone knows upfront, understands really well upfront what this is. And then we discuss about dependency injection with abstractions. So from that I understand using interfaces to tell Spring what you need to inject in a specific property or parameter. We have already discussed in chapter 3 that dependency injection may happen either in the field directly or the parameter of a constructor or method. And we have discussed different ways in which we use wiring and auto wiring. aka dependency injection. And the only difference that we discuss in this chapter is that Spring knows how to inject values not only when you specify a concrete object that you need from the context, but also when you specify a contract, telling Spring not necessarily I want a specific object, but I want an object that can do something, and you don't care what implementation will be provided. You don't care what implementation Spring provides in this case. You want to have any implementation that complies with the contract. And that's the biggest difference. But why is this so important? Why is it essential? Because this is how we create decoupling among objects. Objects, they need one another, no? That's how a Java application works. That's how an object-oriented programming application works. It's composed of object instances delegating to one another. So one object uses the responsibility of another to define its own responsibility. This is how you see object-oriented programming. Is the collaboration among objects of different kinds to get to a final result, which is processing some data in a certain way, no? But when we implement these algorithms using objects, one of the essential things that any developer, in my opinion, should learn from the very beginning when they start studying is that these objects need to be decoupled. So in many cases, you don't want to create a powerful link between two or multiple objects. You want them to be as decoupled as possible, no? Loosely coupled. This is how we refer to this quality of your application. When the objects don't depend directly one to another, we say that they are loosely coupled. And it's important that, because being loosely coupled, you can very easily replace one with another, and that's helpful in cases, in configuration cases, for example, when you have different environments and you want objects to behave differently in different environments. But it's also very important when we test, because this is the way in which we can easily change an object to a mock, so that we can fake its behavior to test all the possible behaviors of another. So that's why. And of course, when they are loosely coupled, changes when you continue the implementation of an application, changes in one object will unlikely affect the others that depend on it. So many reasons to consider a loosely coupled design, and that's why this is one of the most important design patterns that we follow there, and things that you learn from the very beginning. Okay, so I've started talking too much. I want to get back to the object. So to the chapter, and I said that we start a discussion with what interfaces are. Okay, what decoupling means, and so on and so forth. So you can see that this is basically what we start with here, and I will tell you a couple of stories, because I like that. It's a story that I have also here in my book. It's a short paragraph that should tell you the importance of contracts and why and when exactly we use them. Well, when we use them in software development, that's it comes also with experience, because you will see that it's not like you have now to use it everywhere, because using them everywhere it creates a too complex code in some cases. So it goes into over engineering if you do that. But we will figure it out. So let's discuss on it. So I also see something in the chat. So one of the class contains static method, some basic logic. So I can use direct without creating a bean. Is good or bad? Not sure if I understood the question. So you have a static method. You call it without creating a bean. When you do something like that, so we do normally avoid static methods in object-oriented applications, because you see static methods, they are not behavior. When you do that, you are no longer working in an object-oriented way. Which means that you will not have many of the things that come with working in an object-oriented way, including inheritance, polymorphism, and others. So in many cases, using static methods is not good. Now, I cannot say in your case it's not good, because static methods exist for a reason. They can be used sometimes, but in general, we need to make sure that when we use them, it really makes sense to use them. And in most cases, we prefer not to use them. Being that your topic is not necessarily very related to what we are discussing, I will stop here with the explanation. But if you really want, we can chat on it in a totally different video about static versus non-static, because this is something basic and out of Spring scope, let's call it like that. It's more like Java fundamentals rather than Spring. But I'm glad you asked the question. So I also say hi to everyone. I'm happy you are here with me, and already many people joined. So I was telling you a story, and I was telling you that at some point when I was a kid, I was, of course, I was breaking everything up, and I asked for a knife, and I remember I asked for a knife to use to unscrew some screws, what I've learned at that point is that I'm in my mind, using a knife. I think I saw someone at some point doing that, using a knife for that, and I understood that the purpose of a knife is to use it with screws. But yeah, when I used that, well, my dad didn't want to give me a knife, of course, because I was anyway just a kid, so hell knows what I could have done with a knife. I could have cut myself. But he also told me, hey, what exactly do you want to do with a knife? Why do you need a knife? And then I realized that the question I asked was not correct, because I didn't ask telling the purpose of what I'm doing. I have asked directly for a tool that I didn't even know exactly if it's appropriate for my scope. So instead, of course, that gave me a screwdriver, and then I used that, and he explained me that it's better to use it because it's more comfortable, because you don't cut yourself, because of course you already know why it's better to use a screwdriver. So point is, and what I've learned from that experience many years ago, is that when you ask for when you need something, if you don't know exactly what you ask for, it's preferably to explain what's the usage, what do you actually need. So for example, I might be in vacation somewhere, okay, I have the choice, I need to go somewhere. I need to go to a specific location. I'm on an island, and I need to reach a specific, I don't know, shop, or a specific restaurant, or a specific point of attraction. And I'm going to the hotel, and I ask the people at the reception, hey, wait, I have multiple choices. I can ask, hey, where is the closest bus station? And that's one possible question. Or I can ask, how can I reach that restaurant? How can I reach that point of attraction? Which of the two questions is best? I would say the second one is best, where instead of asking for something specific, I am asking for an abstraction, but an abstraction that provides the purpose, meaning that it offers the flexibility to whom I'm asking to give me alternatives which might be better. They can say you can get there by bus, but they can also say, hey, it's easier if you take a taxi, for example. So see the difference. When you ask for something specific, you will get that something specific. But when you ask for the purpose, it gives the flexibility to whom answers you to give you a better choice after all. So there might be different choices, there might be different implementations, and you get the right one. And that's exactly how it also works with objects. So in cases where different environments might provide you different different implementations of a specific dependency, it's best that you ask for a behavior rather than asking for a specific object itself. Now let me give you, of course, a programming use case. So you have a method that at some point needs to send notifications. But assume that there are different ways in which notifications can be sent in different environments, and in some cases, in some environments, some of these are available and some may not be available. So for example, you might send notifications by email, you might send notifications via short messages, SMS, you might send them as messages on WhatsApp, you might send. So there are different ways in which you send notifications, but you have several environments where your application is deployed and you don't know upfront in that specific environment what will be the ways available of sending. So what do you do in that case? In the environment, you will probably have one or more ways of sending the notifications, and most likely you will like one of them to define as a primary, so that it's the one chosen in case it exists. But then when the object sending the notification that implements some logic and makes sure that it sends some notification at some point, instead of asking for an object knowing how to send mails, or asking specifically for an object that sends WhatsApp messages, or asks for a message that for an object that sends SMS messages, it just asks for, give me some notification tool, give me some object knowing how to send a notification. So the object itself, it doesn't care which implementation will be provided, because that anyway depends on the environment, which it doesn't know upfront. So instead of asking for a given implementation, it asks for a purpose and gets an implementation which is appropriate to the environment. So that's one of the cases where we use interfaces. We define contracts, and we have two. Let me go down below. So now I'm actually using, I'm actually giving an example. No, but in this case, it's sorting or doing something. Okay, so in this case, you see the object uses directly another object. So when you have an interface, and probably which happens down below here, see, this is some object needs to sort some details before it's printed. This is fictively called delivery details printer, uses a sorter by address, meaning that we can imagine before being printed, some details are sorted by their address, whatever that is. Okay, so you can implement this direct usage, but then if you do that, you stick with this dependency, and you will not be able later to replace easily this object with another one, especially, for example, with different environments. So the reason we use interfaces is to decouple it. And I was telling you, so the interface defines the contract, meaning it specifies some behavior, and there are two main sides of a contract. The side using the contract, so who's using it, and the side implementing the contract. So we say, that's why we say we implement. Remember, we use in Java the keyword implements. An object implements an interface. It doesn't extend an interface, no? It implements an interface. Did you ever ask yourself why do we say with classes, why do we say cat extends animal, where cat and animal are both classes, but we say I don't know, we say object implements interface, no? Like dog extends, I don't know, bark. I don't have a good idea now to give you an example, but the point is we use implements. Why implements and not why extends for classes, implements for interfaces, and why extends between interfaces and contract doesn't implement another contract? No, because when you use implements, it means that you use the side where a given object makes sure that it provides a real functionality as described by a contract, meaning as described by an interface. The interface being, in fact, the structure in Java allowing you to define contracts, meaning a set of behaviors that we expect someone will be able to use and someone will implement. So in our case here, to decouple this direct usage between the delivery, the two fictive objects, delivery details printer and sorter by address, we introduce a contract. Doing like this, we have now the object using the contract that defines one or more methods representing the behavior in the contract. So the methods inside an interface, they represent the behavior. It's like in the contract you have the points, like in a real contract, no, that you sign with a company, for example. You have some things that are guaranteed. That's what a contract does. It guarantees something for both sides. When you sign a contract with someone, you are guaranteed that what is in the contract will be fulfilled for you, and the other guarantees that they will fulfill what's in the contract. So that's basically why we use this interface. So we decouple this way. We guarantee the delivery details printer that they will receive an object that gives a purpose to a method called sort details. So that's why when you use now in the logic of the delivery details printer, you use the sort details. You use a sort details that looks like it doesn't have an implementation, because you know that actually at the runtime you will get an implementation. You don't know how that implementation works, but you know that you will get an implementation for this sort details method. And then you might have one or more implementations, meaning as many objects as you'd like, that implement in a way that sort details. And then when the code really executes, it will get, in fact, one implementation. Exactly as I was telling you, the object doesn't now request directly a knife or a screwdriver. It requests, in fact, something to use to screw screws. So it tells what its purpose is. I want to sort details, but it doesn't tell exactly what they want. It will be at the runtime when it's decided, and it can be decided in several ways, what exactly object will they get that is able to sort the details. And this way it can get different implementations, for example, either in different environments or in different kind of logic. So I see in the chat something. Could you explain how design by contract and interfaces can be used? Can we use abstract classes for design by contract? So Mehmet, it really depends what you understand in design by contract. because it's not clear for me. When I use the term design by contract, for example, I usually refer to endpoints or to collaboration between different applications. It's not really common, at least not as I found it, to discuss design by contract between objects. But normally when you say design by contract, it actually means you create a contract and then you make sure that you create the object satisfying the contract. That could work in any case where you refer to a contract. And then can we use abstract classes? Abstract classes are totally different structures in Java. They are not defining contracts. So no, you cannot use abstract classes to define contracts. Abstract classes are only a way in which we can accumulate different characteristics of several objects through inheritance without having to repeat them throughout all of them. Like, it's a way in which we can write less code. But in many cases with abstract classes, like, it can be the abstract class can be replaced with simple dependency of objects. So when we create the design in an object-oriented application, we need to make sure if the abstract class really is what we need there. But anyway, just to answer your question, you don't use abstract classes for contracts. Interfaces are the only structures in Java that you use to define contracts. And in what extent do we have no pre-post invariants? I don't understand at all this question, so I'm sorry. I really don't know what you mean by in what extent do we have pre-post invariants. I don't know. Maybe you can detail a bit. Okay, so going back meanwhile to our explanation here. So we decoupled with an object, allowing now the flexibility of having different implementations, or allowing the possibility to change easily one of the implementations with another. So when do we really use an interface is, of course, if you go through the book, I'm gonna go quick because I don't want to spend too much time. I have already discussed what I think is essential, and hopefully you did understand. The examples show you how to implement that with code, and it's nothing exotic here. So instead of directly using the object, see the difference here? The class defining the delivery details printer object was directly referring to a sorter by address, which was an object, an implementation, set as an attribute, and in this case injected through the constructor, as you can see here. Instead, we use the interface. So sorter is our interface. You can see it how it has been defined here. No interface and the abstract method representing the contract itself. And now instead, of course, this class doesn't say I want that specific kind of sorter implementation. It says I want a sorter, whatever that is. So what this object is pretty sure about now is that it will receive something that implements the sort details method, but it doesn't, of course, know exactly how will that sort details method be implemented. So now I think this chapter goes through a scenario. So I created a scenario because it's unlike the examples that we went through with chapters 1, 2, and 3, where we have used parrots and owners and dummy objects. When we now go more and more into more complex things, it becomes less and less easy to use simple POJOs for our demonstration. Anyway, we don't even want to do that. The book needs to be practical. We want to approach things that you will then use in real world apps, and you will not use in real world apps parrots and dogs and cats. So that's why we will step into let's call it a little bit more complex scenario. So I'm going to go through the diagrams because I know it's easier. I don't want to read the book for you. You can read it yourself. You can take the book and then read it. And I do recommend you read it line by line because there are a lot of juicy stuff in there that will help you become a better developer. So what do we do here? We have a comment service object that implements a method named publish comment. And then to implement this publish comment method, it uses a repository and it uses a notification proxy. The repository implements a method named store comment that stores a comment in a database. We can imagine that, no? While the notification proxy has a method named send comment that sends a notification with the comment. Good. So let's analyze a bit this diagram. First of all, just to make sure that we all understand the terminology. So when we refer to service, when we say service, it usually means an object that implements a use cases. Usually the service classes are those in a so-called layered class design. In a layered class design, services implement the business cases. They implement a given logic defining a use case, so a complete definition of a transformation of data from one point to another. That's why service classes are also usually the ones that implement the ones where you will often see transactions being defined, and they are also very often places where you will see security annotation placed over the methods, because that's what you create as being atomic in a transaction. You put the use case in the jar, let's put the use case in the balloon, and the same is with security. That's what you secure. You secure an entire logic rather than securing usually only one piece of it. No, you secure that the user can send a comment, publish a comment, that published comment might represent multiple things that can happen, including storing the comment, sending the comment, and others, being that usually in real world applications things might be a lot more complicated. While repository is usually an object in a layer design, it represents the object that stores data somewhere. In most of the cases we talk about a database, be it relational or not, we call the object a repository. But of course, the repository is just a generic term, so it might be, for example, that you store in the cloud, like in an S3 in AWS. In that case, the object where you implement the logic that integrates with the AWS S3 might be as well called a repository. You can even store things in files, and in that case, it's still the logic of a repository as long as the file would be used to store data. So repositories are in general in a layered architecture understood as objects used to store somewhere the data and make it available when needed. And in the repository you might have behavior to store the data, but also behavior to retrieve the data. So it's the object that communicates with a given way of managing data storage. And of course we have proxies, which usually are objects that implement communication with a different service, with a different system. Like you create a proxy to call another microservice, or you create a proxy to call service an SAS in cloud, or you create a proxy to communicate with someone else. No, like in this case, you might imagine that send comment uses a different service to send the comment through a notification, a WhatsApp message, an SMS, an email or whatever else you want. Okay, so the question is then, because we are still at section 4.1 where we don't discuss Spring now, we still discuss applying interfaces and contracts. Again, telling you that this is really important to understand before. I don't want you to go into technicalities of Spring without understanding properly what a contract is, what an interface is, and how do we use it. And the question is, where exactly would you implement here interfaces? Which of the objects, in this case, I have 3 objects here, which objects in this case would implement an interface? Or another way to put the question is, or to rephrase it, is which objects would need a contract, would need to implement a contract, so that when they are used, who's using them has the opportunity to easily get a replacement when needed. And then the answer for that is that in most cases, if we would take this diagram, in most cases, the command repository and the command notification proxy most likely would need to be decoupled, but the service class, in many cases, in most of the cases, it doesn't make sense to have an interface of its own. And you will find out there, I found out in many cases, apps that I'm consulting, people have created interfaces for service classes, and in most cases they don't even know why they did that, because usually interfaces on service classes, they are not needed. I can tell you why in some applications in the past they were needed, but today, like most developers, simply just put them there because they started working on an app, and then they simply use the copy-paste programming as a pattern to implement new stuff, but they don't ask themselves the question why they do that. So why and when do we normally use interfaces, and why on this diagram most likely the command repository and the command notification proxy would need to be decoupled while the command service doesn't need this? Because we do create decoupling where we expect to either have several ways to implement the same behavior, or we want to be able to somehow test another object, the one that's depending from the other one, by replacing it easily with a mock. Or we expect to have several changes in the future in that. Now, when we take the repository, store comment might need to be changed, because throughout the time we might have several ways of storing that comment. So it's best if you don't stick to a given implementation, so that you can easily change the storage at some point. Imagine that store comment would store now the comment as a file in an S3 in AWS. There is cloud doing this. You would stick to a specific technology on a specific cloud. But if you implement this in using a contract, then you would have the benefit that you don't necessarily you don't stick too much, don't chain yourself too much to a given cloud. And then you might, for example, change this implementation, and in the future, because let's say your company observes that AWS became too expensive for them, and they would be rather more advantaged by using Dropbox, they implement the implementation of the same command repository that stores the comments in Dropbox. And this way, if you have decoupled the command repository, the only thing you need to change is the implementation of command repository. Command service will have no idea that now the comments are stored somewhere else, because it was completely decoupled. You understand? So it's exactly, imagine that the way you have a contract with your GSM provider, with your phone services provider. You have a mobile phone. If they change the infrastructure or whatever they have there technically, you are not affected anyhow. If they change their antennas, and you still can make calls from your phone, from your mobile phone, you don't care. Why you don't care? Because you don't care how many antennas they have there and what kind of antennas they used, as long as they respect their contract, meaning that they provide you the services you are paying for. The comment service here, in the same way, it will not care and it will not be affected being completely decoupled if we use an interface. And the same with the notification proxy, same explanation. Now, why don't we create an interface for the comment service? Because the service class, as discussed a few minutes earlier, a service class in general, it implements use cases. Now, it's rather unlikely that you will have or need different implementations of a different use case. It's either you have one and you change it, or you don't have it at all. I mean, you don't have multiple ways of what it means transfer money. A use case is transfer money. Imagine that. What does transfer money mean? It means usually one thing for an organization. It can't be that transfer money for the same bounded context means two different things. So see, in that case, you know that you don't have multiple implementations, so that's why service classes don't need usually interfaces. They can be directly linked to whoever exposes them, because we don't expect to change them anyhow in any way. So that's most likely why you see this diagram later, where you see how we, instead of having the service directly linked to the comment repository implementation, now this is an interface, and the interface is used. So this is the contract used, and then we have two objects, each one implementing the contract. So you see the sides of the contract. Comment service is the side using the contract. DB comment repository and email comment notification proxy are the sides implementing the contract. And a very important thing, friends, which is again more like a best practice, do please avoid that kind of implementation, you know, that kind of comment repository IMPL implementation. That's an anti-pattern. That's a code smell. Why? You anyway know that if an object implements an interface, that's an implementation. There is no need to append impl at the end of an object class title to prove another time that that's an implementation. On the other hand, always your interface name must describe the behavior that's in the contract, while the implementation needs to, from the title, clearly describe how it implements that. This is a best approach. So comment repository, the interface tells me that whatever I get here as an implementation will be a repository for comments. Already tells me everything. And then the implementation is named DB comment repository, already telling me from the title of the class that this is a comment repository implementation that uses a database. This is a comment notification proxy that sends a notification by email. See, this is the best practice. This is how you have to name your classes and interfaces. Okay, it's not impl. That's anti-pattern. Please don't do that. I don't want to see in your code anymore this kind of anti-patterns where we don't know how to write a class name and we simply put interface name impl. Same with interfaces starting with I. Doesn't make sense, no? Okay, and I would prefer, like, here you can see the implementation, and I'm pretty much sure that you already know this. I don't want to go too much through this discussion, and I would like to stop here because it's only like 15 minutes left, and I don't want to leave the discussion at the middle. So in the next discussion, we will go, in the next episode, we will go through finally using this in Spring, and I will explain you how Spring is smart enough to use interfaces when you need them. And I use this episode as a bridge, and I use this section in my book as a bridge also to make sure that people understand interfaces and contracts. And remember, it's very important to understand them properly. And next time we will discuss on how to use them with Spring, and you will see that Spring knows how to use contracts, and that is really helpful. So what do you think of the capital letter I at the start of an interface name? I think it's not needed. I don't see any relevance of putting an I in front, like I comment repository. Is that helpful anyhow? Some might debate on saying that you know that this is an interface before jumping inside the file. However, now with IDEs today, usually they anyway have a different way of showing. If I correctly remember, for example, IntelliJ shows it in italics, so it's not necessarily needed to put an I in front of the interface name. I wouldn't say it's as bad as having that name and impl, but it's not needed either. So for me, it's still a code smell, to be honest. Can you recommend some GitHub repository to learn Spring Boot? Not at the time, but I will think about. I mean, the majority of the people dealing with Spring, like for example Thomas Vitale, Josh Long, and so on, they have their repositories which are really good. Now I know that they generally have complex, like more complex case and examples. Probably what you ask me is something more less advanced, something like that. And I don't have some repository in mind, and I can only refer to, for example, if you like my playlist here, the Spring playlist on my YouTube channel. It has the GitHub assigned, and you find there all the projects that you have from the playlist as well. So maybe that can be helpful. And of course, you have the projects coming with the Spring Start here. So they are not in they are not in a GitHub, but you can actually, anyone can get them. They are not they are open. No way anyone can get them. So if you search here my book and then you book on Manning, for example, Spring Start here, you go to the page, to the books page, and then you have somewhere on the left here source code. So you have access to the book's source code, and that applies to any Manning book. Okay, so now I told you how to get the projects on for any book from Manning. Cool. Thank you very much. I would like to close it here. One more question, and then I will close it. What roadmap would you recommend for someone who is absolute beginner to programming all the way to Spring? Well, I do recommend, as I stated in other videos as well, you start with the very basics, and then I would go with basics of Spring and basics of Hibernate in parallel usually, and then evolving from there more like tree-like rather than linear. But please do search on my channel, because I have already videos where I discuss recommendations, and I have promised I will create more, and I will actually put some more live events of this kind on my channel. Cool. With that being said, I'm saying again, thank you very much for being here with me. Hope to see you also in the next episode, where we continue the discussion on chapter 4 and discussion on how to use interface with Spring. And until then, I'm waving goodbye, and I'm telling you have an excellent time for learning further. Cheers.